One of the things we often use in graphs is actually distance time diagrams. The first thing they'll give you is maybe only give you whole hours or something like that. So you've got to work out maybe how much each of these ones in between is. So if there are 3 different distances that are equidistant between 12 and 1, what's the time that's gone on between here? This one here will be 12:20. This one here will be 12:40. So each of these distances represents 20 minutes. What can we say about these 3 people that are out walking, running, jogging? Which of them's going to be the fastest? Well, the easiest way to find that out is, let's take a whole hour, because that's nice and easy to work. And let's see approximately how far John goes in 1 hour. So we do a perpendicular line from the x-axis up to where we see John actually travels in 1 hour. And then we can measure that it's 5 centimetres for 1 kilometre, and here we've got about 5 centimetres. So we can say that in 1 hour, John travelled 1 kilometre. So what was John's speed? John's speed, we know, is defined as distance over time. And we can see that it's constant. It's constant because it's a straight line. He's not going faster, slower, faster, slower. He's keeping the same speed over the time. And he's travelling a distance of 1 kilometre over a time of 1 hour. So his speed is 1 kilometre per hour. Then if we were going to look at Jane then, well, we'd take the same time. It's the easiest. Take 1 hour and see how far does Jane get in 1 hour. We just follow the distance up from, draw a perpendicular line, and it's very important that it's perpendicular, going up here to Jane, and see where it cuts the curve. And we can see it's actually 10 centimetres here. So Jane is travelling 2 kilometres in 1 hour. So what is going to be Jane's speed? Well, Jane's speed will be distance over time, which is 2 kilometres in 1 hour. So she's travelling at a speed of 2 kilometres per hour. So the steeper the graph gets, the faster the person's running, of course, because in the same distance they're going further. Jim then, if we follow Jim's line up from 1 hour, we see that he ends up at 20 centimetres. So he's travelled a distance of 4 kilometres in 1 hour. So Jim's speed, which is distance over time, is going to be 4 divided by 1, which is 4 kilometres per hour. The main thing to understand here is it wouldn't have mattered where we decided to take the distance over time. We're doing rise over run wherever we do. Rise here was 4 kilometres, run was 1 hour. If we decided to do it over 2 hours then we'd have taken Jane's speed, for example. We'd have taken from 2 o'clock and we'd gone up to where we meet Jane's curve. And here we've got the distance of 4 kilometres divided by 2 hours. The time was now 2 hours. 4 divided by 2 is still going to give us 2 kilometres per hour. So the nice thing is that it doesn't matter where you decide to measure. So you should always look for points on your graph that go through. You usually get a grid like this. Don't take the smallest point down here that's really difficult to read and then divide by 20 minutes, so you have to divide by 1/3 of an hour. Take it where it cuts through one of the coordinates, like this one. Let's see. Here's a point that cuts through both the x and the y. It makes it really easy for me to read off the y value and the x value. So always look for those follow the straight line until it cuts a coordinate nicely. That's the best way to take your y over your x. Rise over run. Difference in the y-axis divided by distance in the x-axis. So speed time diagrams are really quite easy when you've got straight line equations. And you could represent this by an equation. All of them. It's really easy. We now know how steep this curve is. The equation for John's line is going to be, it goes through the origin, so there's no, the equation y equals kx plus m. None of them are going to have an m, because they will go through the origin. They're going to go through they're going to cut the y-axis at 0. So it's how steep they are. Here, the steepness of this one was 1. So for John, it's going to be y equals x. For Jane, the equation of the line is going to be y equals 2x. And for Jim, the equation of his line is going to be y equals 4x. So if I wonder any value of y, when I know the time, when the time is 1 hour, the distance he's going to go is 4 times 1, 4 kilometers. If the time is 2 hours, the distance he's going to go is 8 kilometers. If y is 3, the distance that he's going to go on is 4 times 3, which is 12 kilometers. So using it as an equation, you can actually work out exactly how far he's going to go. If he's carried on at that speed for 48 hours, we'd get the distance that he would have gone after 48 hours.